So today we're learning about real numbers, and this is our introduction into integers. Integers are a part of real numbers, the real number system. So we're going to talk about all the parts of the real number system, starting with the kinds of numbers that you know about, counting and natural numbers. So counting numbers are also called natural numbers, and they include 1, 2, 3, 4, etc. It doesn't include zero, and it doesn't include fractions or decimals. It's just basically whole numbers without the zero. So believe it or not, zero is a harder concept to understand than 1, 2, 3, or 4, or 5, etc. Because you can kind of count those, but to count zero is a little more abstract. So when you first learn about numbers, you learn about counting numbers, 1, 2, 3, 4, etc. Then you learn about whole numbers. Whole numbers includes the zero. So when you were a kid, you went from learning about counting numbers or natural numbers to whole numbers. So you learned about the concept of nothing or zero. So whole numbers are just that, whole numbers, no fractions or decimals, they're only positives, and it includes zero. Next, you learned about integers. So you learned about this in 5th or 6th grade. And integers are whole numbers and they're opposites. So we do include zero, and then we have the whole numbers, 1, 2, 3, etc., and all their opposites, -1, -2, -3, etc. Integers do not include fractions or decimals. So when you use the word integers, you're not talking about fractions or decimals. And now, zero does not have an opposite. Zero means nothing. There's no such thing as the opposite of nothing, right? It's just nothing. All right, so next we have rational numbers. Rational numbers is where we get into having fractions and decimals. Rational numbers include integers, which include whole numbers, which include counting numbers. So rational numbers have whole numbers or counting numbers like 1, 2, 3, 4. It includes zero. It includes negatives and positives. It includes decimals. It includes fractions. It also includes repeating decimals. And it includes what's called terminating decimals, which are decimals that will end at some point. So here are some examples. -2, that's an integer, so it's also a rational number. 3.5, 2.75. Now 3.5 could be written as 3.5, which is a terminating decimal. It's a decimal that ends. It ends after the tenths place. 2.75 is a terminating decimal. It ends after the hundredths place. 0.3, repeating, is a repeating decimal. 0.45, or 45 hundredths, is a decimal that ends in hundredths place, and -1/5 is a decimal that when you convert it, the fraction to a decimal, it's -0.2, therefore -2/10 is a terminating decimal that ends in the tenths place. The other types of numbers that we have are called irrational numbers. Irrational numbers are numbers that when changed to a decimal go on forever with no pattern. So, for example, pi is 3.141 blah, blah, blah. We all know pi really goes on forever, but we round it to 3.14. 3.14 is not really pi. That's a rounded version of pi. Pi, to be more exact, on a calculator, you would use the pi symbol instead of 3.14. because the pi symbol would put a lot more digits in than 3.14. Anytime you take a fraction and you convert it into a decimal, if the decimal goes on forever and there's no pattern, that's considered an irrational number. And you'll see more examples of irrational numbers in higher level mathematics, but the one you're all familiar with right now is pi. So now we're going to practice identifying each number, each of the following real numbers, as either a counting number, a whole number, an integer, a rational number, or an irrational number. If the number is multiple things, like for example, if it's if it's rational, the rational number will also be an integer, a whole number, and a counting number. We'll list all of those. So take a minute and see if you can figure out what each of these will be, and then we'll check back. Okay, so 6 is a whole number, a counting number, an integer, and a rational number. Do you have any questions? -8. -8 is an integer and a rational number. 2.5 is a rational number. -1/3 is a rational number. 5/11 is a rational number. And when I first put this next one into my calculator, I did not see a pattern anywhere, so I thought it was irrational. But it was pointed out to me there actually is a pattern if you take the decimal place out far enough. And the nice thing about your computer calculators is you can make your screen pretty big. And if you divide 17 by 23, you will find a pattern. Therefore, it is rational. So again, the main irrational number that you guys will be familiar with right now is pi. That's the only number you've really found so far that goes on forever. And we'll talk about that later. So negative means opposite. That's ultimately what it means, right? Because aren't integers whole numbers and their opposites? So negative means opposite. So this first notation we have here, a negative with 6 in parentheses, means the opposite of +6, which of course is -6. The next one says the opposite of -6, which is 6. Good. So that's all those negative symbols mean. So if we have the opposite of 6 plus 5, what's that?
-11.
We have the opposite of -7 plus 5, what is that? +7 plus 5, which is 12. So the sign of a number tells you the direction of a number, like traveling west or east. Negative is west, positive is east. Or negative is the opposite direction of the positive direction on a number line. So you start at 0, and to go in the positive direction, you travel east. Negative direction is west. So negative means opposite, as we just talked about. The opposite of 5 is -5. The opposite of -5 is +5. So then absolute value is different than opposite. Absolute value means the distance from 0 on the number line. And then the notation is to have 2 vertical lines around a number. So here we have 2 vertical lines around 6, and that's read the absolute value of 6. The absolute value of 6 means the distance from 0 to 6 on the number line. So let's look at that. So the distance between 0 and 6, here's 6, is going to be 1, 2, 3, 4, 5, 6. Okay, that's no surprise to anyone. What about the distance from 0 to -6? So if we're looking at the absolute value of -6 right here, what that means the distance from 0 to -6. So that's 1, 2, 3, 4, 5, 6 also. So regardless of whether you're finding the absolute value of a positive number or a negative number, it means you're finding distance. Distance is always positive. I'm going to say that again. Distance is always positive. So when you find the absolute value of a number, the answer will always be positive because it's the distance from 0 to that number on the number line. So what would be the absolute value of 4?
4.
What's the absolute value of -10? What's the absolute value of 3?
3.
Good. Always makes it positive. So we've already gone over the next page. Now let's do the following page. What's the opposite of -17?
16.
What's the opposite of 20? What's the opposite of 5 plus 4? What's the opposite, or excuse me, what's 3 plus the opposite of -4? 3 plus 4 is 7. Now we're going to move on and talk more about absolute value. So what's the absolute value of 2? Absolute value of -2. Right, absolute value is distance. Distance is always positive. So what's the absolute value of negative 5? What's the absolute value of 5? What's the absolute value of 9 minus 2? Now, in this case, you treat your absolute value bars like parentheses in your order of operations. So you do what's inside your absolute value first, then you take the absolute value. So I should see both of those steps. In the next problem, again, we do what's in absolute value bars first. So what's the absolute value of negative 5?
5.
What's the absolute value of positive 5? What's 5 plus 5? Again, I should see all of these steps because taking the absolute value is a different step than actually completing any arithmetic. So now we have the opposite of the absolute value of 7 minus 5. So we want to do what's inside of our absolute value first. So what's 7 minus 5? Okay, so we keep our notation, the opposite of the absolute value of 2. Now we take the absolute value next. What's the absolute value? It's 2. So the opposite of 2 is negative 2. Next, we have the opposite of the absolute value of negative 14. So we take the absolute value first. What's the absolute value of negative 14? 14. Then we put the opposite symbol in front of it to get negative 14.